So AngelOne is a 28-year-old organization, right? So we have got legacy of 28 years where we are helping clients to build their portfolio, build their wealth using the stock market instruments for our last 28 years, right? What does this legacy also means in terms of technical challenges is that we have got so many technical legacy systems built in over that period of time, right? And you guys must have also be aware about that after COVID, the stock market is like so many everybody want to invest into the stock market, right? So after that we got a challenge of keeping up with the kind of scale which we were seeing, and our legacy systems were not able to match to that particular scale, right? Hence we rolled out a new app which we call super app, right? So these are some glimpses of our app which you can see here. You can also visit our stall where you can also play around with the app and experience it. And some of the key numbers which I would like to call out here is that we have more than 22.2 million client base as of today. Before we started the migration, this number was in single digit, right? And this is the kind of growth which we went through over last two and a half year, and we had to actually modernize our lot of systems. So why we had to modernize, right? So this is the landscape which we had before we started the migration. We have multiple client applications. So mobile applications over Android, iOS. You will have the desktop browser-based application. You will also have a thick client, exe, which you actually install on your computer, right? Then we had so many applications here. A lot of them were legacy and a lot of them kind of semi-modern, which were created over some new tech stack over a period of time as part of the new feature development, but still we had to reconsider them for our modernization process, right? We also integrate with a lot of entities, right? Be it stock exchanges, various depositories like CDSL, NSDL, banks, and so many other systems to provide the seamless investing experience to our clients. So our problem statement was this, right? We had to actually modernize all these systems, right? And the legacy applications, as you all have already experienced that, faces a typical challenge, right? Being 28-year-old organization, there may not be a person named Carl, right, who had actually built the system maybe 20 years back, is no more working, right? Might have taken the retirement from the industry. So how do we fix those kind of features or any defect or implement new feature, right? So we had to actually start on the modernization journey, but there are multiple constraints when you start the modernization, and which we had to go through. So I will brief about some of those. So our business was growing, as I have explained already, and there was a lot of demands, feature demands from the clients and our business partners, etc. Right? So we cannot just say them that okay, we will not implement anything for next 6 months and we are building something new. There was always continuous demand was coming from business and clients to provide the new features, right? Right. So that caused in a lot of issues like feature parity. So whatever modern system you are building, but you need to support those new features today, right? But you have the legacy system running out today, right? So you have to implement those on the legacy system, and then you are running into a cycle, re-implement those in the new code base, right? Implement on the old code base. So a lot of churn was happening in those areas. Then this industry is very regulated, where SEBI, exchanges, government, lot of government agencies play a lot of role influencing what we are supposed to do. And during this last 3-year period of time after COVID era, there was so much regulatory compliance requirements to safeguard the interest of the investors, like everyone like us, right? So that we also had to make a lot of changes to fulfill those compliance requirement, right? So many changes were happening in that front too. And finally, we had zero risk appetite to do any kind of this migration. So we cannot just implement new system, migrate, and break our system tomorrow. How many of you trade in the stock market? If anybody do option trading or anything? Anybody does? Options, futures? Right, so imagine say we suppose you are trading with AngelOne and you took some option position, and tomorrow you are not able to sell it, right? And we say that, oh, we are working on the migration, we just deployed the new version and it's not working, right? This is totally unacceptable for any client, and unacceptable for you. This is equally unacceptable for the regulators. They are going to come back to us, impose a lot of fines and penalties, do the audits, RCAs, etc. So we had zero risk appetite. We cannot break anything at all during this modernization journey, right? So essentially, it's a metaphor. We are not changing the engine actually, but it's a metaphor that our flight is running. It is in flight. Our clients are sitting inside the plane, and we had to actually change the engine, right, without going down, right? So this is what we started. So we started our journey in two tracks, right? So one important point to remember here is that legacy system is still working. That is serving the today's traffic, today's clients. Modernized system is something which we are thinking for the future, right? So we had to equally give the weight to our existing system so that we can at least survive during the period when we are actually implementing the new system and rolling it out. So we started a program to ruggedize the existing systems on one track. On a separate track, parallelly we started the modernization journey because we want to move away from legacy as soon as possible. So two tracks were started in parallel, and when we started the ruggedization program, we had to keep the lights on. So it was the main objective, right? Don't let our system go down, just keep it on until we have a replacement available. And to keep the light on, very first thing which we often miss out in the legacy system is the proper monitoring and alerting, right? Say imagine you have some old code written in store procedures, etc., very old COBOL code or anything. You may not have the proper new age monitoring, right? Grafana, Prometheus, etc. You are not able to monitor your system. You come to know your system went down only after your clients are complaining, right? So very first thing which we built on this is to have the monitoring, alerting, our eyes and ears, so that we can at least understand our system, at least keep a watch on it, right? While we are doing this, other thing which we figured out is this logging is not sufficient. And the legacy systems, the old way of software writing, lot of times people will write logs into a database table, right? Then how do you put the search on those kind of things, right? There was no Splunk or Grafana or Greylog during those time when people wrote those legacy system. So we had to spend a lot of time on fixing the logging, right? So that those logging can help us in the debugging of any issue or any incident which happens in the legacy system. And then these two things were very important for us to stop the firefighting. Another thing which happens with the legacy system in many organizations is that your core team is always busy in the incident calls with the existing system, which is every day that is breaking. Team is spending so much time on fixing the issues, spending all the energy, and then manager expecting them to work on the new features also, right? So it is not a good thing or good expectation from the engineers also, right? So what we had to do, we had spent our time on stop the firefighting. So we had identified the issues, why a system is failing. Is this a scalability issue? Add more servers, right? Is the single point of failure? Remove those single point of failure and fix the low hanging issues, right? The issues which are causing the more problem. Let's spend some time, spend some energy to fix those issues in the legacy system so that we can spend our energy on building the new system, right? So here we had actually spent lot of effort parallelly on stabilizing the existing system so that we don't have to spend so much energy there. Once we are done with this, while this is happening, so yeah, one tip is here, right? So while all the senior in such situations, all the senior engineers and leadership will move into building the new system because that is more fancy, right? You are using clouds and all the new technology. But one of the great learning here is that all the senior engineers in the organization, in the leadership, should also attend the incident call, incidents which are happening on the legacy system, right? Because if you are designing something which is desirable, but you don't know what is the problem happening every day, right? So then you are designing something just on the paper without understanding the real problem. So all the senior people should also understand the pain point of the existing system and make sure that those should not arrive in whatever new system we are building. Otherwise, we are back to the square one, right? We might have the new system built in a new language, new platform, maybe move to cloud, but every day you will end up facing the same problem. So this is one of the tip from our side for the engineers. Now we went into the modernization part of the track of the process. So here, so every engineer just want to start coding, right? I mean, you got a problem statement, you will open your draw.io or any system, build some design and start coding, right? So here we had to control our urge of jumping into the solutioning. We spent a lot of time here on choosing our long-term tech stack, because we had we understood, right, our legacy system, what kind of use cases we have, what kind of use cases are coming, then what should be the right tech stack for solving those problems. So we divided this whole process in 3 parts. So first part is the assess. So we assessed multiple technology, programming languages based on our experiences or current trends, right? And then after assessment, few of them will go into the trial, right, where based on the study you can easily filter out few of them. Then you go into the trial mode, you do a lot of POCs, and after you are done with the POCs, finally you adopt a particular tech stack, right? You may choose. So we here selected Golang as our primary language to write our backend services, Python for our data stuff, and many more, like what databases we want to use, which caching solution we want to use. So all such things we selected through this. We also created many recipes for our team to work on, right? So we created common patterns which every developer need to implement continuously, right, to implement many features. For example, your fan out calls, fan in calls, how do you merge the responses, timeouts, so many things, so many use cases comes, right? How do you how one service makes an HTTP call to other service with proper timeouts, retries, and all such things. So we built lot of common patterns, and we built lot of operational guidelines for managing our infra. How do you do disaster recovery for Redis? How do you set up your Redis cluster? How do you set up your, for example, say RDS or any SQL database or anything? For every tech stack which we are using, we created all the recipes, guidelines, how we want to use it. And we tested those thoroughly and made sure that those are actually fulfilling our SLAs and kind of RTO, RPO which we need. Once we are done with this, we created a lot of chases and batteries. This means that we created starter projects and we created a lot of examples to solve the common use cases. So with this groundwork done, now our team can scale. Our team can actually start cloning our starter projects and start referring our sample implementation and start churning out the new features quickly on the new platform. Right, so we spend a lot of time on this particular aspect. Once this was done, then we moved into identifying various design patterns which we can use to actually do the migration from legacy system to the new system. And remember that we cannot break our application for a minute also, right? So for that purpose, we figured out few design patterns. So a strangler fig is very widely known design pattern. Martin Fowler also talks about it many times. So a strangler fig is a tree found in Australia where, so you can see in figure number 1, there is a tree and then a branch comes out from the tree and eventually that branch becomes the tree here completely, right? So this pattern takes the idea from this particular behavior of the nature, and we use this as one of the fundamental pattern for our modernization. So we incrementally rewrite a small part of our system. So for example, right, so say there is a facade layer in between, right, but it's not there every time, right? If you are lucky, you have some kind of layer in between, some middleware, right, then you can actually use this pattern. If there's a facade layer where from your client is making call to facade layer, you have a legacy system on the left side, right, and these legacy systems are kind of monolith, right? So you can actually pick and choose one portion of the feature from here and implement in your modern architecture, modern code base. You may decide to take this over whatever cloud you want to use. Maybe this part is on your data center. This part you can implement on wherever you want, in whichever language you want, because you are restricted by this facade. And when client is making a call, you can route your request to whichever place you want to, right? So this was very basic pattern which we started using by slowly moving one piece at a time. And in case something goes wrong here, you can easily fall back to the previous one, right? Because your old system is anyways running, right? So and once slowly everything is modernized, then you can decommission your legacy system here. Then next setup pattern which we employed here is the vertical split. So as I explained in the initial slide, that we have multiple client applications. We have Android application, iOS, web application, thick client, right? The problem with mobile applications are you do not control the rollout too much. You can roll out the new version of the application, but your client is still running the very old version of the app, right? And also the problem with the legacy application is a lot of things can be hard coded. Maybe your endpoint is hard coded, which you cannot easily flip by DNS or any other thing, right? So those application will anyways make call to your whatever endpoint which is hard coded, your old system, right? So here we increment. So what we did was let's take the example of Android application. So we had this old version of the Android application which is making a call to our legacy systems. So we actually built a whole new application, new Android application, registered as a new application on the Play Store, right? And we started implementing the new features into this, right? And this, so whatever new feature we are building, those will get integrated with this one, and but all features are not modernized at the same time. So this can still make a call to the legacy one, right? Incrementally, when you are keep modernizing your backend systems, you will keep adding, keep moving them to this one, and at the same time you have to make sure that you are completely shutting down your old application. So we have to do force upgrade of the previous versions so that people will get forcefully upgraded to the new version of the app, etc. So by that we had to get rid of the old application from the market in a slow pace, because we cannot cause the disruption to our millions of users in one shot. And finally, when your app is gone, then half problem is through. Then we can anyways slowly move the legacy applications to the modern tech stack, here, and then get rid of legacy system completely, right? And the another one which we built is the loopback. This is a kind of anti-pattern. Don't use it without proper thought, giving proper thought to this, understanding the proper SLAs and guarantees of your application. So what problem we had was, we have a web application. So when we rolled out the web application, everybody will start using the web application, right? Because there's not much of mobile app kind of thing where people are installing on that, right? They will point over URL and they will open the new application. And there's a legacy application, mobile application, which you are using on your old mobile phone. So say, let's take the example of watch list. So you added a stock into this, through this system, into the watch list. Now sometime you are using your mobile application also for trading. Now you want to see those things here, right? But this system is talking to legacy, and which is talking to this database, right? So how do we give this data to this, right? Because I do not want to make any code change on this piece of the software, right? So what we did here, it's a kind of hack. Here we built an adapter. So whenever a mutation is happening to this database, we are also calling the say post API on this, or whatever API this is, right? So that the data is persisted here also. There can be failure point that your data is persisted here, but for some reason this thing fails, right? So there can be some failures, and you might incur some cost here because you are doing some additional work other than your normal read and write traffic, right? So this has to be very carefully thought through, like what is the failure scenarios in this, is this acceptable? For us it was acceptable, say for 1% of the time clients are not able to see the watch list on this, maybe client will again add it, right? So there is no huge cognitive load on the client side in case this fails for 1% of the time, but it is solving the majority of the use cases. Right? So we implemented this, and once our legacy system was decommissioned completely, we removed this part completely from this. Right? Same can be implemented other way around if say you want to do loopback from legacy to the modern, which is generally very little chances because you do not want to make changes in the legacy code. But yeah, we did from modern to the legacy side writing back. This one is very important pattern which we followed here, which helped us a lot. So in broking industry, there is a lot of features which are very calculation sensitive, right? Whenever you are trading, your brokerage charges needs to be calculated, government taxes needs to be calculated, your risk management needs to be done, like how much money you have in your account, are you allowed to trade or not. So there were a lot of those capabilities available in the legacy system, and a lot of things which we were not even aware about how this will work, how this thing works, because these are very old implementation. Nobody knows how it works, right? So how do we write those things into the modern? You do the re-engineering of the code, and you try to figure out lot of things. Still, you can miss some of the edge cases. So in this case, what we did, we also followed that kind of loopback kind of pattern here, a little bit anti-pattern, but helped us here that actual traffic is coming to legacy system, and we implemented a router here which is actually shadowing all the API calls onto the modern system. So modern system, your new code base is running in a shadow mode, right? And then you can compare the output, right? So maybe end of the trading session, you can compare the output of both the system and say, okay, what is the deviation? If I have all the API call coming to this, will I miscalculate something, or is everything okay, right? If you figure out calculation delta into this, then you can actually focus on those specific use cases, right, where you figured out the delta and dig deep further and find the issues and fix it and run it again, right? So once we achieved the 100% accuracy here, then we slowly started migrating traffic to the modern system, right? So this worked for the transactional system. In broking industry, lot of things also happens in the batch mode. So once you purchase a share during your trading day, actual settlement happens during the night, right? When all the exchanges and depositories and government agencies, RBI agencies, everybody coordinate with each other to actually align on the consensus that how much money we need to give this client back, how much share we need to credit or debit from that particular account. And so much calculations happens every day on the data which we trade during the trading time. So all those batch processes runs during the night. So we had to modernize our batch processes also. So we followed the same thing every night. Both legacy process and the modern process will do all the calculation and write their output in some files or whatever database is their output location, and then we will do the comparison of those. Once we are 100% satisfied with this calculation, then we take the modern system live. And anyways, legacy system is still running until we run the modern system for a few months. So in case you figure out a new use case after a week or so, either you can fix it on the modern system if that is easy to fix. If you figure out something which is very like weird, you don't know, we simply roll back to the legacy one. So for many months, both the systems were doing the calculation, writing the output, and then we build the mechanism to quickly flip. In case one calculation is wrong that day, then we simply flip our table or data structure so that your portfolio points to the other calculation output. Right? This is very easiest one. If you are on the semi-modern kind of structure where you already have, say, API gateway or Nginx reverse proxy or any load balancer, then if you are building any modern system, you can simply use the content-based routing, maybe the /API v3 to v4 version, right? You can, based on the content and your endpoints or header or anything, you can easily route your traffic to your whatever target system which you are building. Right? It's pretty straightforward, which we started doing for the semi-modern application, which we had to rewrite. And the final one, yeah, and one more which we had, one more use case which we had. This was interesting use case. So being this kind of clientele, right, where we have 22 million client, any feature which we roll out goes to all the clients. So one of the few use case which we had got, that where we want to roll out that feature to a controlled audience, maybe to our QA team, right? So until they test it, we do not want to roll it out to somebody, right? And they want to test it on the production version of the application. They already tested on the UAT, pre-prod, everywhere, but they want to test on the production application which client will see. And if I start giving the search results on the app, then everybody will see, right? Then we had to build some kind of rollout controller here, some places where it's a more finer grained controller where you can do the routing based on the JWT token, your client IDs, or some regex pattern. Right? Using these, you can control which audience sees your new version of the implementation, right? So that you also limit your risk, you limit your blast radius. Say 99% of users seeing the legacy implementation, which was working fine for decades, and the only 1% of the audience seeing the new implementation. Right? Then, yeah, so we implemented this, and once everything was rolled out, this was completely decommissioned. And finally, one of the easiest one and most underrated pattern which is in the industry is using the DNS for your migration. So our DNS maintains the records for the IP, right? Your name to IP mapping records, where say AngelOne.in, right? It points to say 4 IP. Now I want to remove those 4 systems, add the 4 new system, right? So what we did here, just update your record. So initially say these 2 legacy IPs are there, so 50% traffic will go to them. So DNS will do the kind of load balancing at this level, right? Then we added our new system's IP, modern system IP here. Then DNS itself end up doing 33% of load balancing on this. This is not the accurate 33% because you are resolving your DNS, but roughly it comes out to the those allocation. And once you want to get rid of the legacy application, you just keep adding your modern system and remove your legacy IPs from here. So all the traffic will start going to your modern system. You automatically stop the legacy system here. And then during this journey, it was not like that everything was very easy and working very fine. We had few incidents, we had lot of learnings. Even we aspired to had 0 incident kind of migration, we still had lot of learnings into this process. So one of the incident or learnings which we had was the premature or incomplete modernization. So as an engineering team, we always like to jump into the coding, open your coding tool, Visual Studio Code, and start writing, right? We do not want to write documentation or understand how old system was working. So we also made the mistake. We build the new architecture and everything, but we miss out few use cases on the old which legacy system was supporting. So which we had to actually hurry up later, right? And here we feel that we need to document everything from here onwards, right? And this document is also important for the second learning. So whatever is legacy today was modern someday. So whichever system we are blaming today, saying that oh, this is bad, this poorly written, why they would do like this, all such thing, right? Imagine that they had run the company for 28 years, right, using that software, and whatever we are writing today will become legacy after 4 years or 5 years. Technology will change, right? New patterns will come, new tools will come. Nowadays trend is like that: you sleep one night, morning you wake up in the morning and you will have a new UI framework coming up, right? So we have to actually appreciate the people who have actually built and maintained those legacy systems. If we are not able to maintain them, imagine that how much effort they have put for maintaining those systems. And also we can leverage the people. They may not be technically versed in the newest languages and newest tech stack and everything, but we can leverage them as a SME for the features, right? They understand those whole system very much well than whatever we can do by the looking at the code and logs and everything. And we also run into a lot of incidents of running the parallel modernization, and the critical path was breaking. So many systems were coinciding with the deployments and everything. So this is one thing which we need to avoid. And whatever new features which are building on the new old system, right? We have to make sure that we are prioritizing them and talking to a stakeholder clearly, because you will implement it twice. Implement on the new tech stack and on the new tech stack, right? So there need to be very clear conversation with the all the stakeholder in the organization, and everybody need to be bought in for this kind of modernization journey. And last, always think about rollback, right? Because something will go wrong. It will definitely go wrong. Not the day you roll out your new feature, maybe after a week it will go wrong. And if you don't have a clear playbook of rolling back to your previous system, then you are stuck. Then you have to fix your system overnight, test it, roll out, and hope that it will work. Right? So always, whenever rewriting any new code, always think about how you will roll out this thing. If something fails, how you will roll it back to the previous version. That's it from my side. Thank you.